One, go.
Hello, my name is Dakota Holmes, and my partner's name is,
Matthew Faulk.
and we will be creating an app that gives a tutorial on basic data path processor design. And how we did that was we used Visual Studio Code with React Native, and I downloaded an Android simulator onto my computer to easily run the app back and forth so I can look at what's going on. And how you do that is you just have to do npm start, which is right here, and that gets everything going, pulls up this. If you have Expo app, you can download that and you can um, pull
Uh,
up your camera app and hover over this and you can pull it up and it'll automatically go to the Expo app and show the application that's being worked on. And once you get to here, it says press A to open Android, press A, and this will automatically connect to the phone simulator and pull up the app that we have created. Now, that being
um,
said, go for it, Matt.
all right. So yeah, this is the homepage of our Datapath Design tutorial. The primary purpose of creating this application, well, we know how the computers can be kind of a mystery to people that aren't into the computer science realm, and we wanted to demystify the way that it processes instructions and works like in a general way. So we decided to create a beginner-friendly mobile application that will kind of give the overall gist of how the CPU works. We wanted to give it a balance of going a high-level understanding and a low-level understanding. So it begins with the general overview. Um,
Wait, before you get into that, Matt, I want to tell them that we had to import this special library that we found online so we can use the collapsible views that we have here. And the collapsible views are also known as accordions. All right, go on, Matt.
okay, yeah, so those were super useful. React Native overall allowed us to focus on the content rather than fiddling around with front end development. But we did style everything ourselves as well as the implementation of the actual accordions. Um, yeah, so we wanted to begin at like a general kind of high level understanding, and that's what's in general overview. If you open that. Um, so yeah, it begins by giving a brief description of what the CPU is and a basic one at that as well. And then we just break it into two sections, which is the data path and control. And that's kind of how we decided to format our whole um, application is kind of first describing the data path and then the control. So next, yeah, as he's showing you, we have the data path preview, which is we wanted to give a brief visual aid to kind of give the user the experience of what the data path looks like at a general level. We then moved into the data path elements because we thought that if you went straight into describing the instructions, like the ALU instruction, load and store, then it would be too complex for someone to understand, like a beginner. So we wanted to describe each piece of the data path before we went through and brought them through how each instruction actually works all the way through it. So we begin
For
by the
example,
yeah the
go
ALU. I
ahead.
guess you can describe that if you'd like.
Yeah, for example, we have the ALU, we have the adder operation and the basic ALU. We have both of them right here. This one's the adder, and this is the basic one between the register file and the data memory, and that is controlled by a multiplexer, which is our next data path element that we have here.
Right.
It just go for it, Matt.
Well, yeah. So the multiplexer, we wanted to make sure that the user knew that the multiplexer is given life by the control signals, and so that's kind of what we went with there. The register file, we described how it has 32 general purpose registers. We also included information about the program counter because that's vital for understanding how we get to the next instruction as well as how it works with branch. And then we mentioned the stack pointer, but we thought that it was at too low of a level for understanding at this
Too
place.
difficult to understand.
Yeah, and it's not
And then we
really
have,
necessary to generally understand the data path. Next was instruction memory. I guess you can explain that if you'd like.
yeah, we have the instruction memory here that states elements that are only needs to be read because the data path does not write instructions. The instruction memory only reads, so that's the only thing that it does. And then we go to the data memory. It's a readable and writable memory. Uh, it comes from either the ALU to the A or the data memory. The only way to know which way it goes is to add the logical elements to steer the data in the right direction.
Right.
We have a little picture here to show that. And then we
Lastly,
have our
we had
little,
the logic gates. And while you don't really need these to understand the data path, we thought that it would be nice to give some insight into how the gates work. So we just gave a quick description of those. Next, we decided before you even get into instructions, again, we needed to understand the general stages of how all instructions are processed through the CPU. So
mhm.
we wanted to give general descriptions first. So fetch
Yeah,
is kind of basic. I guess you could go through these if you'd like.
yeah, there's the three sequential stages and simple instruction execution. The fetch, which is fetches the instruction. The decode, which determines the opcode, which bits needs to go to which register and whatnot. And then the execution, which is this would read the register files and perform the operation that is fetched.
Right, and so the
And
execution
so,
stage we described, depending on the instruction being processed, this could be making comparisons, performing reads, writes, or calculations as well. And
yep,
then at first we had our design where we were teaching you control signals before any of that, but we reworked it to give it a better presentation of kind of a like linear progression of the depth of knowledge. So yeah, we didn't want to just give the user whether the control signals are a 1 or a 0 for each data path for each instruction and not explain why. So we had Cody decided to put in all of the general like what state the control signal is in, whether it's a 0 or 1, and what that is doing, so that whenever you go and look at the instructions, you can come back to this and say, okay, memwrite is doing this, mem2reg, its purpose is this. So yeah, we wanted to make sure that the user had a thorough understanding of why the control signals were there and what their purpose was.
yep. And now that leads us to our last collapsible view, which is, in fact, I think the most difficult and has the most information inside, because this is where everything is all put together. And so we have the four basic instructions, which is ALU, load, store, and branch. And each of these have their own two collapsible views nested inside of them. And that will be the execution of the specific instruction and the control signals of the specific instruction. And this tells you the value that each control signal has and why. And the execution portion is taking you through the steps that goes through, like, help me out, Matt.
Yeah, so we showed the necessary data path elements that we had already stated above, so you can directly kind of come down from there and you know which elements that it's using, because not every instruction uses all of the elements. I want to say something, as load and store instructions are similar, but we decided to split them up because of the key difference that store does not use the write back function of, or write back register of the register file. Um, yeah, beyond that, we just walked the users pretty thoroughly through every single stage of the execution in every instruction, describing which registers are used, where the operands are going. Um, for load store, we just described the offset, as well as for branch, calculating the target address with PC plus 4, and then we described how you shift left 2 to to co- um, to bring it back to 4 bytes, because we're going to add the offset to the current program counter to get to our target address. So yeah, explaining all of this at this kind of level of understanding where anyone could kind of get it if they read this thoroughly was really difficult. We had to do a lot more research on how it works, not just at like beyond what the slides said, the lecture slides. We had to go back and read the book um, about how all of this works. And as Cody's showing you, we had lots of styling for everything. We decided to split it up. We can talk about that, I guess, for a sec. You
Yeah,
want to
I'll
talk
go ahead
about
and
the
talk about it.
styling and how it's all
Yeah,
goes
yeah, for
down?
sure. So, like I said, we imported this collapsible view from um, eLive 2 that we found online. We're very thankful for it because it's really helped us out in our project, and I really like the way that it was presented online. So we chose this. And how we implement it is just we have to do scroll view outside of all the collapsible views, so you're able to scroll and you can go up and down. Um, Inside of that, we have the text, which is just the basic title, and we have a little a styler with its components at the very bottom on how we want the data path design tutorial to be presented on the screen. And that's where it is at the very top for the title. And then on the inside of that, this is where we start making our collapsible views. So like, for instance, this collapsible view right here is only the general overview. There's none nested inside of it. It's just the basic collapsible view. We had it styled how we wanted it to look. The title right here, that it's styled. We had it black. We gave it a specific font. Um, the style, the border swag, that gives this border right here its thickness, its color, and its square shape. Also with the arrow styling, normally just the standard arrow was much smaller and black, and it didn't have any rounded edges. So with our styling, we just we implemented the specific attributes that we needed to make it rounded and make it colorful and easier to look at. And so I think that's what we did with that, and I think it looks pretty good, to be honest.
Yes.
So
So I had used React previously by myself, and I knew JavaScript, but it was really nice to kind of get into React Native, where it's specifically for mobile app development.
hmm
Um,
and I think this was Matt's first time using React Native. Maybe not. I don't think. Maybe it was definitely mine, and I really enjoyed doing it. This was a great project, and I think I learned a whole bunch from it.
yeah, so you could show the styling. We wanted to have it kind of with this hierarchy that made sense. It got a little confusing because there's so many different styles for all of the nested objects.
Yeah,
Um,
but we decided to do this so we didn't have to redo it over and over again. We just had to do it one time, and that's how we did it.
yeah, exactly. By placing your style sheet at the bottom of your um, JavaScript file, you don't have to make inline comments or inline styling at the top, which would make the code extremely messy. Um,
So, kind of like for instance, we have the heading, which is right here, and then we have like a subheading, or for the nested ones, it'll be the ALU, and then for the double nested collapsibles for like instructions, we have three different headings. So we have specific font size for heading one, specific font size for subheading, and then specific font size for subheading content, which would be this collapsible view right here. So kind of um, just all they're all relatable, but just a little bit smaller than one another, so they're easily read and able to differentiate where is what and what you're reading, and it's not all kind of just mashed together.
right. Okay. Well, I guess we can go ahead and start our conclusion. I would say that working on this project with high level tools, that was kind of what Cody and I wanted to do at this beginning. We knew a lot of people were doing like low level kind of projects. We wanted to combine high level tools with the low level microarchitectural concepts that we learned this semester because we're interested in web development and he wanted to know more and I knew a little bit about it already, but now both
hmm
know a lot more than we did. So yeah, it was really nice to kind of see how that could come together, and I feel like describing all of these things and teaching them it this way kind of reinforced our learning that we had learned everything that we had learned all throughout the semester, and
Yeah, we should have done this before the last test.
before the test would have been super useful because now I feel like we understand this more than we ever did.
Yep, I'll be
So
using this in my parallel programming class.
yeah, so I guess that's all that we have for today. As a conclusion as well, we have it working 100% on Android. On iOS,
Mm,
there's only one small bug that sometimes text will run off of the screen. But he is running it on Android. There, it works 100% on Android. We tested it on several phones, and then we plan to improve this throughout the summer and completely polish out the iOS, and then perhaps even
Hopefully put
add,
it on our, yeah.
yeah, and add some more functionality to it as well.
Yep.
I
Um,
guess, is that
I
all?
hope you enjoyed this app as much as we made, as much as we did making it for you.
All right. Well, that concludes our presentation.
Thank you.